What is Laplace transform? Laplace transform is an integral transform. Suppose f of t is a function defined for all t greater than or equal to 0. The Laplace transform of f of t is defined by L of f of t equal to integral 0 to infinity f of t e raised to minus st dt, and it is usually denoted by capital F of s. And here f of t is called inverse Laplace transform of capital F of s, and it is usually denoted by L inverse f of s. For example, suppose f of t equal to 1. Laplace transform of 1 is integral 0 to infinity 1 into e raised to minus st dt. That is, on integration you will get 1 by s. Another example, f of t equal to e raised to at. Laplace transform of e raised to at equal to integral 0 to infinity e raised to minus st into e raised to at dt. On integration you will get 1 by s minus a. Another is a condition for existence of Laplace transform. Laplace transform of a function f of t exists under these conditions. One condition is f should be piecewise continuous on the given interval. Another condition is f should be of exponential order, that is, modulus of f of t less than or equal to k into e raised to at, where k is a constant. Under these two conditions, Laplace transform of f of t exists. Now we have some standard functions and their Laplace transforms. Laplace transform of 1 is 1 by s. Laplace transform of e raised to at is 1 by s minus a. That of t raised to n equal to n factorial by s raised to n plus 1. T raised to p in general, that is gamma p plus 1 divided by s raised to p plus 1. Laplace transform of sin at is a by s square plus a square. That of cos at is s by s square plus a square. Laplace transform of sin h at is a by s square minus a square. Laplace transform of cos h at is s by s square minus a square. Now we discuss one of the fundamental property of Laplace transform, that is linearity property of Laplace transform. Suppose f1t and f2t are two functions of t having Laplace transform of f1 of s and f2 of s. Then Laplace transform of c1 into f1 of t plus c2 into f2 of t is equal to c1 into Laplace transform of f1 of t plus c2 into Laplace transform of f2 of t. That is c1 into f1 of s plus c2 into f2 of s. This is an example for the property Laplace transform of 2 plus 5 e raised to minus 2t minus 3 sin 4t is equal to 2 into Laplace transform of 1 plus 5 into Laplace transform of e raised to minus 2t minus 3 into Laplace transform of sin 4t. That is 2 by s plus 5 by s plus 2 minus 12 by s square plus 16. These are some more examples of linearity property of Laplace transform. Now we have to discuss some properties of Laplace transform. One of the first property, one of the important property of Laplace transform is a first shifting property. That is, if Laplace transform of f of t equal to f of s, capital F of s, then Laplace transform of e raised to at into f of t equal to capital F of s minus a. That is, in the Laplace transform of f of t, s is replaced by s minus a when f of t is multiplied by e raised to at. Second property, multiplication by t raised to n. That is, Laplace transform of t raised to n into f of t is equal to minus 1 raised to n into the nth derivative of capital F of s, where capital F of s is the Laplace transform of f of t. We are differentiating with respect to s. Now property 3, division by t. If Laplace transform of f of t equal to capital F of s, then we have Laplace transform of f of t by t equal to integral s to infinity f of theta d theta. Now the fourth property, this is one of the important property which is used in the solution of linear differential equations. If Laplace transform of f of t equal to capital F of s, then Laplace transform of f dash of t equal to s into capital F of s minus f of 0. Secondly, Laplace transform of f2 dash of t equal to s square into capital F of s minus s into f of 0 minus f dash of 0. That is, in general, the Laplace transform of nth derivative of f of t equal to s raised to n into capital F of s minus s raised to n minus 1 into f dash of 0 minus s raised to n minus 2 into f2 dash of 0, etc. minus f n minus 1 dash of 0. Now the fifth property is a transform of an integral, which says that if L of f of t equal to capital F of s, Laplace transform of integral 0 to t f of u du equal to capital F of s by s.